Hey Mark, I'll just hand straight over to you to introduce yourself and your topic and crack on.
Sounds good. How's my audio?
Yeah, good.
Okay, awesome. Well, two great presentations before me by Lewis and Adam. I learned a lot about Python and also about the formulation group. So that's always good to see what other people are doing with LabVIEW. So we're going to go right into my presentation, which is on best practices for error handling. And this is one of my things that I really uh, like to talk about. It's important, but sometimes overlooked when we're doing our projects. So we're going to cover that. But what I like to do first is when I do these presentations, I like to give a little introduction of myself as a person, just so you get to know me a little bit about my background. So I do have a few slides that I want to run through on that regard. All right. So my name is Mark Ridgely. How you doing? Happy to be here today. And I'm a certified LabVIEW developer, certified test stand architect, certified professional instructor, LabVIEW champion, and the owner of Radius Technologies, LLC. And Radius Technologies is my own company. It's a huge company of one. I basically do everything from cleaning the bathrooms to writing LabVIEW code. So whatever has to be done, that's up to me. But what I do in my work is a consultant for LabVIEW and test stand projects for any company that needs help with LabVIEW. And when I'm not doing consulting, I do training for NI, so long-time LabVIEW user. So I'll tell you a little bit about where I got my start with LabVIEW. So I started off in the Air Force, U.S. Air Force, as an F-15 radar technician. And I was working in Okinawa, Japan for about 5 years. And this is one of the aircraft I actually worked on. We were known for the double Z marking on the tail. And in this picture, the aircraft is deploying flares, which is a countermeasure for heat-seeking missiles. Shows what we did. We were flight line maintenance, and you can see some of the radar components there in the open panels of the aircraft. And aircraft would come back with a problem. We would troubleshoot it down to the box level, pull the box, tag it like the one that's in the foreground, and then we'd send it into the shop where they would repair the internals of the unit. So that's what we did on the flight line, just keeping the jets flying. After I left the Air Force, I was fortunate enough to get hired as a NASA subcontractor at the Kennedy Space Center. And this picture is showing one of the first projects I was assigned to. That's a Space Lab module. And this thing is about the size of a small school bus. You can get an appreciation for that by looking at the people in the lower left hand of the frame. And in this photograph, we are hoisting the module to install it in the open payload bay of a space shuttle, which is down at the bottom. Here's a photo of me working inside a module like the one you just saw. So doing some kind of electrical installation. And then after that, I was lucky enough to get assigned to work on the space station project. And we had the contract for doing the final integration testing and monitoring of all the elements of the space station, because everything launched through Kennedy Space Center. So the countries that built the modules would ship them to Kennedy. We would receive them, do the final installation and integration testing. Sometimes we would actually cable 2 or 3 pieces of these together on the ground just to make sure that once they were connected in orbit, that everything would work. So I did that for about 9 years. Very interesting work. Worked with people from all around the world, worked with astronauts, and had a lot of fun doing that. So it's really good to know that that's still up there doing its job today. This is showing the space shuttle on the launch pad. This is where I actually wrote my first LabVIEW program. And to date myself a little bit, that was done using LabVIEW version 3. And after that, I fell in love with LabVIEW, and I liked it so much that I became certified as an instructor by the time LabVIEW version 4 came out, So I've been using LabVIEW since version 3 and been teaching it since version 4. So a long time user and instructor. But the project we had was we had a power supply that was installed in the base of the mobile launch platform, and our module would be installed inside the payload bay of the orbiter. And that was 430 feet of cabling between there. And we had to make sure that our power supply would regulate and would trip off under certain transient conditions over that length of cable. We did that using a big racked 40 kilowatt DC load bank. It was 26 600 watt channels of loads that you could combine in different configurations, and then we could apply transients by stepping that load in different ways to verify the transient response of our power supply. We got tired of doing that from the front panel, punching buttons. They asked somebody to write software, so I volunteered and I just picked LabVIEW to do it, and the rest is history. Been using LabVIEW ever since. This shows where I'm located in the U.S., so a little bit across the ocean from you all. Red circle is Minneapolis, Minnesota. And the other pins are places where I've gone to either do consulting work or training for various companies. So that's the introduction for me. Now we'll talk about the agenda for the rest of the presentation. And we're going to start off talking about planning. Then we'll talk about which errors to handle, getting a handle on it, logging it, putting it to the test. Then we'll see some examples from the real world, things that I've ran into as a consultant. And those are real world examples. All right. And finally, discussion. All right, so planning is key. Whenever you're doing an application, you want to plan your error handling up front. You shouldn't really implement it as an afterthought, which unfortunately is what happens in a lot of cases. People just want to get their code working, doing what it's supposed to do, and error handling comes up just on an as needed basis. Something goes wrong, then you decide, oh, I better write some code to keep that from happening. But ideally, you want to start with a plan, because critical applications, you need to have more complete error handling than regular LabVIEW code. So that does take some planning. Also, when you go to develop your error handling strategy, you usually are going to be talking about these things. It's going to increase your development time, right? And not only do you have to plan it, but you have to write the code to support it. So you will have an increase in your overall development time. Also, there can be performance trade-offs. So you have to think about that as well. If your error handling is happening, all the time after each operation, for example, if you're checking for errors, that's going to obviously impact your performance. So you have to weigh that in your planning. If a section of code is very critical and error handling is essential, then maybe the trade-off in performance will be acceptable based on the level of risk and hazard. All right, so one of the first questions you want to ask is what errors are most likely to occur, right? You want to think about the most likely errors and try to address those and handle those in your error handling strategy. So for each error that you identify, then you have some additional questions to ask. What's the severity of that error, right? You want to handle the most severe errors that have the highest negative consequences. So what's the severity? How should the system respond, right? You definitely want to think about that before it happens. What's the effect of this error on subsequent code, right? Something goes wrong. What does that do to other downstream code? What does that affect? What should be the effect of this error on subsequent code? That's two different questions. What's the actual effect and what should it be? A lot of people don't answer this question until it's too late. They write some error code and they go, oh yeah, this looks pretty good. I wrote it to do this if something goes wrong. And then in real usage, that something goes wrong and it doesn't actually affect the rest of the code in a good way. And they hadn't planned for that. So you definitely want to ask this question. All right, so we want to think about those errors that affect subsequent code, because that's the part that mostly gets overlooked. For example, not all code is going to behave the same in the event of an error. So we have to think about that as well. So if you're shutting down your application and you write your code the way it's shown on this slide, it looks good, right? You want to stop your lamp, you want to stop your fan, and you want to shut down your system. And we've got the error chain connected through everything. And you would think that this is great code, right? The developer did everything right. They're using the error cluster just like they should everywhere. However, you want to think about what happens in the event of an error, because if there's an error coming in here, you're probably not going to execute these nodes, because recall that the normal error behavior of nodes in LabVIEW is that if they get an error in, they don't do their operation. So in this way, this code is written here, you likely are not going to stop everything and shut down. So you want to think about that and maybe write your code a different way, perhaps like this, right? So we want to ensure that all those stop functions will execute regardless of whether there's an error coming in from the rest of your application. And these are things that developers don't normally think about. You know, they think that the first code that we saw was good, and then they run their system and they have an error and their system doesn't shut down, and they're left at a loss. Maybe they have to manually go, you know, shut off the equipment or something like that. So something like simple like this, just changing your code and thinking about what happens, what will actually happen, is key. So we need to think also about which errors we should handle. So we want to make sure we only handle errors that we can actually do something about, right? I mean, there's no point in trying to handle something if you have no control over what the outcome is. So only handle things you can actually do something about. You want to ignore errors that happen in your error handling and shutdown, right? Because we always want those operations to run. So we want to basically ignore any errors coming into your error handling and any shutdown code like we just saw. We want to focus on the critical sections of code, right? Those are those things that if something goes wrong, the penalty is high, right? It's a severe cost. So you want to think about that mission critical sections of code and focus your efforts on that. You want to document any assumptions that you make regarding error handling. Also document any errors that you are not handling so that people understand that when they run this system, these are the assumptions and these are errors that we do not handle. You want to use code reviews, right? That's going to help you reach consensus about where to focus your effort on developing your error handling strategy. I've worked with customers and talked to their teams where they will have meetings for like a half a day where, you know, there's heated discussions about what is an error and what is not an error, you know, what should be an error. And this goes on because every person has their own idea about what's an error and what's not. So reviewing it up front and with your team is key to decide on what errors you're going to handle, where to focus your effort. And then reviewing the code as well when the code is done to make sure that it's actually written in such a way that it implements what you agreed to. Also, as with any code, you want to keep future changes in mind, right? And you want to write your code today such that if something changes, it's not going to be a showstopper to address that change. All right, so now we're going to talk about the types of error handling. And there's actually 8 types of error handling. And when I've said that in other settings given this presentation, people are surprised that there's 8 types of error handling. So we're going to talk about those 8 types. The first one is LabVIEW's default error handling. Then we have local error handling, where we can either prevent or correct and clear the error. Then we have specific error handling, global error handling, central error handling, error classification and description, and error reporting. Also logging. So all of these things are different ways you can handle an error. And in some applications, depending on the criticality, you may do more than one of these things at a time. Typically you will be doing more than one, right? You're going to have to identify and classify the error. You're going to have to report it, and you're going to usually want to log it. But most people don't think about it down to this level, and especially these 8 types. But in reality, you should be doing probably more than one of these types in your applications. So when we talk about LabVIEW's default error handling, anybody that's been using LabVIEW for a while probably already knows this, but the default behavior for many nodes in LabVIEW is that as your VI runs, LabVIEW is going to check for errors at each node, right? And if there's no error, the code executes normally. But if there is an error, we just pass the error to the next node without executing. And at the end of that, we report it, usually with the simple error handler in many cases. So that's the default error handling. And that's the primary approach for minor errors that can be prevented or controlled, right? These are simple errors that aren't that critical. Also, these errors should not prevent normal execution of your application or system. So some methods for this local error handling is to prevent errors or correct errors after they occur programmatically. We can also choose to clear an error locally. So let's talk about prevention of errors. That's probably the most proactive thing we want to do as developers. If we can prevent something from happening, we should try to do that. So when are we going to do that? That happens during development. That means we've planned our error handling, we've anticipated what errors might happen, and we say to ourselves, hey, I can write my code in such a way as to prevent that. So how do we do that? We determine the possible source of errors. We develop our code in a way that ensures that error can't occur. And some examples of that, if the control value is going to be used as the denominator of a divide, you can develop code that checks that that value is non-zero, right? So that's pretty easy to prevent that from happening. If you have a value that needs to be in a certain range, then you should set control limits on the front panel so that the user cannot put a value that's out of range into your system. All right, next we're going to talk about local error handling. So we can correct errors. When should we correct an error? We could do that at runtime, right? Your code is running, something bad happens, we can just correct it in software. So how do we do that? We identify the error and we take immediate corrective action. For example, if the user selects an invalid configuration file, we could simply create and use a default file that has the most likely system settings already applied in it. Or if the user selects an invalid DAC channel, we could just prompt them to select a valid one. Or if instrument communication fails, we could retry the communication a specified number of times. Now, you want to be careful anytime you're doing something like retries to make sure that you either implement a maximum number of times you're going to retry before you quit if it doesn't work, or you're going to retry for a certain time period and then exit. This one I see as a consultant all the time. Developers say, okay, I'm communicating with my serial instrument. If that fails, I'm going to put code in here to retry 3 times. And they don't test that, right? They never test that it actually retries 3 times. They put the code in service, the error happens, and their code gets stuck in an infinite loop because they actually made an error implementing the counting within that loop, right? So they miss it and they get stuck in a loop. So it's important not only to develop your code in such a way that you address errors, but also to test that code to make sure it actually does what you want it to do when that error occurs. We're going to talk about testing a little later in the presentation. All right, another thing we can do is clear the error, right? If we handle it, we probably want to clear it so our program can continue normal operation. And there's a few ways we can clear errors that we'll talk about here as well. So when should we clear it? Like I mentioned, after we handle it. So we took care of the error, so we need to clear the error cluster. So some methods that we can do as well After we pass the error information to a global handler, if it was more of a critical error, we pass it up to a global error handler, and then we clear it locally. So how can we do this? We can use the clear errors VI. And if you're not familiar with this, it's in LabVIEW. You can just find this in quick drop. And basically any error that comes in on the input cluster is cleared on the output cluster. Now this one, you want to be careful with using this. I've had some customers who had errors in their system and they could not figure out why the errors were occurring. So they just sprinkled this VI all throughout their application. We're going to see this later when we get to the real world examples. So don't abuse this function because it's not for just making errors go away. Another method we could use is the error ring. And if you're not familiar with this, this is a very powerful tool, not only for clearing errors, but for testing your errors. We'll talk about this again later when we talk about testing. So a couple of ways of clearing errors. Also, the empty error cluster you can use as well. So these are all ways to clear an error in your code. Next, we'll talk about specific error handling. And specific error handling, that's code that you call in specific areas of your application to respond to specific error codes. So possible actions that you may take, you could choose to ignore the error. You could retry your operation that had the error. You can correct the error. So here's an example where we have unbundled the error code from the error wire. And then we can have a case structure where the case labels are the error codes, the specific error codes that we want to handle. So in this example, if it's error code -5001, then in this case, we would develop the code that we wanted to execute when that error happened. So that's called specific error handling. Next, we'll talk about global error handling. And you need to have global error handling because some errors affect your system at large. So they need to be handled from the higher level VI. So we're going to pass these errors out of the sub VI so that they can be handled at the higher level. This is for critical errors, right? Things that may affect your system at large. That means your application can't continue running. And generally, these are going to require a safe system shutdown. So methods for global error handling are using the queued message handler. It has error handling built into it. You can create a global error handler VI, and you can use custom error codes as well. So we're going to look at the critical error handling that's in the message handler, queued message handler. In that message handling loop, if an error comes into the DQ VI, it's going to send that loop to the exit case as shown here. So it's just going to drive the code on an error. It's going to drive the code through the exit case and shut everything down. If you're using custom error codes, that means you can create your own custom error messages for use within your VIs and application. And there are some error codes that are reserved for defining custom messages, and these are the ranges. You definitely want to stick with these ranges. If you use codes outside these ranges, it's possible that you would be stepping on codes that LabVIEW uses, and that would be a big problem. So definitely keep within these defined ranges that are designated for user custom error codes. So how do we define these custom codes? If it's for the current application, we could use the error ring that we introduced a few slides ago. The error ring enables you to create your own custom error codes and use them within the error ring. This is how you configure the error ring. In the top pull down, you select custom error code. That will give you field where you can type in the error code there. So you see 5,000 and then you type in a description and that will identify or define your custom error code. You can also use the general error handler VI to define custom error codes. And the general error handler is very similar to the simple error handler, but it adds inputs where you can input an array of your own user-defined error codes and an array of your own user-defined descriptions. And the general error handler behaves pretty much the same as the simple error handler, but it will also display your custom codes as well. So that's the general error handler VI. If you're doing this for multiple applications, then you want to use the error code file editor. This lets you create a file on disk of your custom error codes, and then you can call that file from different applications without recreating all your error codes every time. So this is a nice tool for doing that, the error code editor. All right, now we're going to look at global error handling. This is where you might implement a global error handler VI of your own. So you create a sub VI to handle errors. You use that sub VI when errors could come from multiple locations in your application, because you can call a sub VI where it's needed. So you create the general error handler and put that in each loop of your application. You could also use a functional global variable if you need to share that VI response across all your code. You know, for example, if your error handler determines that your entire application needs to shut down, you could use a functional global to share that. Here's an example. On the lower left side of the screen, we have code, and you can see the red squares there around the general error handling VI. And we are calling that in each loop of our application, as well as calling it at the end of our application to report any errors. And the little blue cone going out to the right shows the code that's inside that error handling VI. So, you know, you would write your code to do whatever it is you want to do and have this sub VI that you can then use throughout your main application. Now we'll talk about central error handling. That's where you respond to classes of errors rather than specific error codes. So we can take asynchronous or system-wide actions. Central error handling does that. So some example, maybe we log those errors to a file, or we display prompts or messages to our operator. We could also shut down or reboot our system. We could apply safe state to all our I/O channels. So we talk about error classification. That's where we organize errors into different classifications. Some examples of that are warnings, critical errors, user errors, communications error. In any case, we're going to probably want to record additional information about these errors as they occur. For example, definitely a timestamp. It's always a good idea to know when errors are occurring. That can give you insight into, for example, how frequently you're having errors, right? You have timestamps. If you know they're occurring every 2 seconds, you know something really bad is going on. Or if, for example, you notice that an error always happens 7 minutes after your application starts, that might give you a clue as to what's causing that, right? So timestamps are important to add to your error logging. The number of occurrences as well. You want to know how many times this error happened. Also the call chain, so that you know which VIs were called all the way from the top down to where the error happened. So that's good information. And the actual data values. A lot of times that's not recorded for errors, but I've had a lot of situations where I get called out to the production floor because they had an error, and I'll ask them, well, what settings were you using on the front panel when this happened? And the operator says, oh, well, we don't remember because we closed the VI, you know, we closed the application. So if you were logging the actual data values and settings when an error occurred, you would not have to ask that question. You would have the data that you need. So these are all things that can help you to figure out what happened, what went wrong. All right, so the next part is reporting errors. That's where we want to tell somebody what happened. Usually the user interface, we're going to target that with some kind of message pop-up or some kind of status field on that interface. So some desirable features of error reporting are understandable messages. And anybody that has used LabVIEW for any length of time, you know that many of messages that LabVIEW puts out are not readily understandable. Usually you have to read them 2 or 3 times. They can be very verbose, a lot of information in there that may not be important. So you want to have understandable messages. You want to localize those messages as well. If your code can be used by people speaking different languages, that's important, right? So you definitely want to localize those. You could elicit a user response as well. Adapt for error classification, right? If you're classifying errors based on severity, those messages should adapt based on the classification. You could use the simple and general error handler VIs. So when logging is up next. So logging is where we create a record of errors for future reference or debugging. So you definitely information that's going to help you. And this is one of those things where, a lot of people won't log errors. And, they say, oh, well, if something happens, we'll just deal with it then. But it's nice to have information about what went wrong readily available. It's going to make your life so much easier when something does go wrong, and things will go wrong. So taking the time to implement a good logging strategy is definitely worth it, but you won't realize the value until something goes wrong and you need that log. All right, so critical errors should definitely be logged to disk, right? You definitely want to know when critical errors happen. So that's going to give you help troubleshooting. The desirable features of logging is human readable, high performance. You don't want the logging itself to get in the way of your application. Limited space or lifespan, meaning you want to limit the file size or how long you retain these logs, right? Because if it's running, whenever your code is running, you're logging things, that file can grow. So you want to put in the ability to limit it based on file size, or you're going to keep the log files for a certain amount of time and then delete them, just so you don't fill up your hard drive. So what do you want to log here? The time, that's always important. The error code that happened, the source of the error. Here's an example of error logging code in LabVIEW. And you can see on the left side, we're taking the timestamp, the error code, the source, and we're using the format into string function there to format that all as a single string based on this format specifiers that are above the call. And then we're passing that into the case structure where we are writing that to the end of a text file, right? And that's important to write to the end of the file so you don't overwrite any previous errors that were logged. So that's one simple example of error logging code. So next up is putting your new error handling scheme to the test. It's critical that you test how your system responds to errors. And this is where a lot of people do not do this part. They write their code, they think they got everything right. Oh, we're going to handle errors just great. Put the code in service, the error happens, and something unexpected happens. So we need to test our error handling before we deploy our code. So some methods that we can do for testing is we can force errors, meaning we can actually do something wrong. Usually that's going to revolve around user type errors, but you could purposefully pick an invalid config file, right? Or a file is not even a config file. You could pick a PDF, right? When you're supposed to pick a text file, you can do that. You could actually physically in your system, maybe disconnect the cable and see what happens. Disconnect the network cable and see what happens if your code tries to run. This trips up a lot of people as well. They have a networked tester and they don't test this, and for some reason either the network is down or the cable, somebody forgot to plug it in when they set up the system, and their code just locks up. It gets stuck in a loop because the network's not there, and so they did not test what happens if that simple thing happens. So we can force errors, make user errors. We could also modify the code to cause an error. If we need to do that, we could do that as well. And then we want to verify our behavior of our system. Number one, make sure the proper error gets reported. This is another thing that trips up a lot of developers. They have an error in the system and the error that's reported is not the root cause error for whatever reason. Usually that involves poor implementation of the error chain throughout the code. You don't see the actual root cause error. You want to verify that the error handling code operates as expected. Again, that's one of the key things. You have to actually test that your error handling code works as expected. When something goes wrong, you need to know for a fact that your system is going to respond appropriately. All right, so we're going to see some examples here now. We're going to look at simple error handling first. So that's code that we call in a central location to respond to errors. Doesn't respond to specific error codes, but can respond to types of errors differently. And it usually responds by shutting down the loop, right? That's the most simple response. So if you're in a loop, let's get out of it. And it's going to ignore warnings. This is sufficient for simple applications. So here's an example. This is the simplest example. If you're doing something in a loop, you got code. We want to make sure that we don't get stuck in an infinite loop. If an error occurs, we can just unbundle the status, put it through an OR gate. So this code, this loop will stop if there is an error or if the user presses the stop button. So that's one of the simplest methods of error handling, right, in a loop in this example. Now there's the structured error handler. If you haven't heard of this, it's a tool, kind of a toolkit that you can download free from ni.com. A structured error handler. It's a reference library, and there's tools for handling errors comprehensively. It's a configurable express VI that handles specific errors. It also has a communication method for transmitting errors and a template for designing your own central error handler, and different support VIs and utilities. And you can download it from ni.com. Just go search for structured error handler. And here's what that looks like in the code. So you see in the oval there, the red oval, that's showing the structured error handler VI. And in the lower right-hand corner of the screen is showing how you can configure that node. And you can put in specific errors, and then there's tabs there for what actions you want to take. Do you want to notify some other parts of your code, and what output you want? So take a look at this. It's pretty nicely featured piece of code that not many people know is available. So go to ni.com, search for structured error handler.
Mark on that one.
Sure.
What's the iteration terminal for? Is that for retries? It can't be retries, can it?
Yeah, I think that is what that's for in this case. Yeah.
Yeah. Cool.
Yep, definitely check it out because it has a lot of good capabilities. So I would recommend taking a look at it. It might not be suitable for all needs, but it could save you from writing a lot of code because it does have a lot of good functionality already built into it.
Yeah, I wasn't aware of that. So yeah, nice one.
Awesome. All right, so now I want to look at some tales from the real world. As a consultant, I work with companies from all different industries and geographies, and poor error handling, unfortunately, is a theme that I run into on almost every job I go on. I find instances of it. So I'm going to show you some things that actually really happened to me and that I've had to deal with. All right, now the first one is a very expensive lesson in error handling. Now, what happened, I had a customer, they were in the transportation field, and they called me because they had a DAC system and they were using triggering to start the data acquisition. They were having trouble with missing triggers. All right, that's what they called me for. So I went there and I was looking at their code. I got all the code and I was looking at it on my own system. And I was paying just attention to the triggering portion, right? That's all they wanted me to do. So that's all I was really looking at. So I started out, tried to run the code, and I'm sitting there running the code, and I hear my hard drive spinning like a jet engine. It just took off like crazy. I immediately started panicking, trying to stop my system, hitting control period to stop LabVIEW, trying to do control alt delete. There was nothing I could do. My system drive was just spinning out of whack. So I ended up just pulling the plug on the system. hard shutdown and killing the power and shutting it off. Then when I tried to reboot the system and come back up, this is what I saw. No bootable devices found. Further investigation of that code, I found that there was a piece of code where they were logging data in a loop. That loop had no timing and no error in it. And the error wire wasn't even passed into or out of that loop. No timing on the loop and no error handling. So it went in there and kept running. The loop just kept running. There was nothing to stop it. And basically it wrote my hard drive until it burned it up. So that was an expensive lesson. I ended up having to buy a completely new laptop. And now I don't put customer code on my primary laptop. I have what I call a burner laptop where I run this code. Because I wasn't called there to look at their data, collection or writing, archiving code. So I wasn't paying attention. I didn't look at every possible part of the code. So lesson learned, a very expensive lesson. Another one is poor error handling. Here's an example of code that I saw. And this customer, they had like 5 loops in their application. And their error handling was written just like this, where the code that was doing the work would write the status Boolean to a global variable. And other loops were reading that global variable to shut down. Well, this is a classic race condition, right? So what they were having, the problem they called me for is that, hey, whenever we have an error, we can't shut down our application. Well, that's because only some of their loops were stopping, right? Because as you see, this loop writes to the global and reads from the global. So the one loop that had the error might set the global Boolean true and stop. But the next loop that didn't have an error would set the global Boolean false. So all the other errors never knew there was an error, right? Or all the other loops never knew there was an error. So that's what was happening in their code. So poor error handling implementation. Here's another one. I had a customer, they wrote their code like this. They put the error in a local variable, and every piece of their LabVIEW code read the local variable in and updated a local variable. So needless to say, they were having problems as well due to this poor implementation of error handling. This one gets a lot of LabVIEW developers. They don't know about this. I actually wrote a LinkedIn post about this a couple of months ago, the zero iteration for loop. Now, if you have a sub VI, as pointed out here, the sub VI is going to output an empty array if it generates an error. Well, if that happens, that for loop is going to run 0 times. And if you have the error wire pass through a for loop on a regular tunnel, if there's an error coming in there and that loop runs 0 times, the output tunnel is going to output the default value, which is no error. So what we want to do is, instead of using regular tunnels, we want to use a shift register on that error input as shown in the code. The shift register will always output the value that was passed into it. So a lot of developers don't know about this. The 0 iteration for loop, tunnels do not pass the input values out. They pass the default value. So take a look in your code, see if you have that. You probably will find some instances of that. Most developers don't learn about this till they have a problem. They realize that, hey, had an error, it didn't come out. The other one that gets lost is a ref num. Let's say where that array of doubles might have been a ref num to a file or something like that. And you have subsequent code that happens after this loop that's supposed to do something with that file, and it won't happen, or you'll get another error saying a null ref num was passed in. That's because that ref num was nullified out if you passed it through this loop on a tunnel and you had a 0 iteration loop. So be careful on that one. This one, overuse of the clear errors VI. And I had a customer that I mentioned earlier. They were having errors in their code. They could not figure it out. So they just sprinkled this VI throughout wherever they were having the errors. And they weren't doing anything about it, but just making them go away. Here's their code. They were doing serial communication, as we see here. And this is their actual code, serial communication. and they had a loop there. And you can see on the outside of the loop, the error cluster from what's doing the work is just terminated with the clear errors. So you're never going to get an error out of their code, right? So they just made errors go away. That was their solution because they were getting errors from trying to read the data. They were having all kinds of serial communication errors. So they just broke the error chain from going through the Visa close function and just terminated it with the clear errors. Their code was actually generating thousands of errors every time they ran their system, and they had no idea that that was happening. Well, they had one developer had an idea because they put this in the code, but after that, they had no idea that they were actually generating thousands of errors every time they ran their code. All right, so that brings us to the question and answer portion of the meeting. So I just want to say thanks for having me here, and I'm always happy to present. So if anybody has any questions, I'd be happy to address them.
Thanks, Mark.
You're welcome.
I was just trying to have a look for that error handler that you recommended.
The structured error handler?
Yeah, I couldn't track it down. I found some pages that were referenced, but they are obviously been removed or something's happened to it, so that you just get an error page when it comes up.
All right.
But
I'll look into that. I don't know, NI's going through their website and changing things, so it's possible that something got moved or accidentally deleted, but I know it was there a couple of months ago when I wrote this presentation, so let me take a look at that.
Yeah, I appreciate that. Wicked.
Yeah.
I've got a question for you. What error handling did you use on your LabVIEW 3 first application?
On my first application, I was very simplified. I did understand the importance of the error cluster, so I did pass that through everything, but I was not really doing logging at that time. Number one, we were just controlling one piece of ground support equipment, so we had the computer was directly attached just to that one piece of equipment, so I wouldn't call it a system per se.
Yeah.
So we were just simply looking for basically hardware type errors. If something goes wrong, we're going to basically put up a message to say what happened, and then we would handle it through user action.
Mm-hmm. Yeah. Nice.
Any other questions or comments from anybody? All right, looks like not. So I'll just say again, thanks for having me. It's always great to get invited to present to groups outside the U.S. I'm happy to talk to anybody that wants to learn a little bit more about LabVIEW. And if you're so inclined, feel free to look me up on LinkedIn if you want to connect there. I'm pretty active on that channel as well. So I'd be happy to connect with anybody in this meeting. And otherwise, I'll turn it back over to Chris.
Awesome. Thanks very much, Mark. And I see, Simon, you posted something in the chat, link to that. Yeah, I got to this page actually, that Simon, that you've put in, but if you click on either of those links, that's where the error comes in. I couldn't quite work out how to.
Just have a quick question though.
Go for it.
Especially like if you imagine you're working in a team with different developers, what would be your suggestion, Mark, for kind of create a standard of error handler among the team itself? Because I know some developers may have different perspectives of how to handle their own errors. And considering your experience, like, what would you recommend, Les? Like, how would you standardize their error handler within the developer teams?
Yeah, that's a great question, and that's where your planning comes in to play. You have to, among your team, you have to discuss this. What is an error, and what should the response to these errors be? You just have to have a conversation because each developer, as you mentioned, they have their own ideas about error handling, and it is kind of very personal, right? And as developers, we take what we do very personal. That I know how to write code that's great, that's really works and robust. So when you have that discussion, it can get pretty heated, right? Because somebody will say that what you've said should be an error, should not be an error, and you just go around. But the key is you have to build consensus, get people to, agree on what you're going to do and go from there. If otherwise you're going to have a patchwork. Each developer is going to write their own VI the way they want to write it. And if you're integrating that all into one larger system, then you have a patchwork that's not going to work well in that deployed application. So you definitely want to talk about it beforehand and document it. As I mentioned in my presentation, you want to document everything you've agreed to, the errors you're going to handle, what the response. You want to document errors that you're not going to handle as well. You want to document assumptions that you're making. So, I mean, that's the only way to really to go about it, is to have those discussions among your team, and you have to get buy-in.
Thanks for explaining that. Thanks.
You're welcome.
Cool. All right. Well, if there's nothing else, thanks again, Mark, and we'll catch up soon, hopefully.
All right. Awesome. Great meeting. Thanks for inviting me.
Cheers, guys. Nice one.
Yep.
Okay. Well, that's also the last presentation of the afternoon, so it's an early finish. We'll be communicating our goal. One more question.
Okay.
Jonathan. Go for it, Jonathan.
I can also talk. So my question is, what would be the best or a good strategy for deciding of which errors to handle in specifically? Like any VI could give out some error, but in an application that can be lots of different options.
That's right. That's a great question as well. And again, that's going to go back to your planning phase, where you're thinking about the errors that could possibly occur. And that can be difficult, but it does require, just a few minutes of thought. You can normally, within 5 minutes, if you think about it, you can kind of think about the top 5 errors that might happen, right? Obviously, you can't think of every possible error, especially where users are concerned. But if you're talking about a system and you just think about it for 5 minutes, you can probably write down the top 5, maybe 10 things that could possibly go wrong. And that's where you start from. So you have to think about it and plan for which errors could possibly go wrong. And then you want to say, okay, out of my list of my top 10 things that could most likely go wrong, what ones are the most severe, right? Which ones are going to damage my hardware or injure a person? And that's what you want to focus your effort on. So did I answer your question sufficiently?
Yeah. Nice one. Mark, someone was asking for your email address.
All right. Let me see if I can put that in the chat here. Let's get that going. Okay. There you go.
Awesome.
That should be there, right?
Yeah, I can see that.
All right. All right. Yeah. So thanks again. Happy to connect with anybody on LinkedIn or what have you. And any questions at all that come up after this, feel free to contact me by any means that's convenient for you.
Awesome. Good stuff. Well, thanks everybody for coming along. Thanks again for the presentations. They were great. We'll be sending off the information of your attendance and presenting to NI to get your points sorted. So if you don't want us to do that for GDPR reasons, all that kind of stuff, then let us know. Otherwise, we'll assume you do. And we'll be in touch about the next meeting in October. and we'll hopefully see you all then. Take care and see you soon.